Warm welcome to all of you. My name is Kuda Sbanda. I'm the one who will be taking you for business statistics. So generally, this is an introduction lecture. I think James should have communicated to you maybe the issue regarding the payments, the amount of money that you're supposed to pay for this lecture, and what it will like what it will cover. So just a recap, you're supposed to be paying $750 for each module, so which means business statistics, you're just going to have you're going to pay $750, and that $750 will cover the lectures themselves, the covering of an assignment, show you how you do your assignment, and also the KCQ. So generally that is the basic information. If you want to know more, then you can go and ask James. So like I said, I'm Kuda. I'm going to be taking you for business statistics the whole of this semester, and I've got a certain manner in which I will conduct my lectures. Unfortunately, I just did this one offline, but from maybe next week, when we start to have all those lectures in person, you need to understand that my lectures are interactive, which means that you don't have to wait for the end of the lecture for you maybe to say something, maybe a question or something, right? So while I'm doing my lectures, you need to understand that you are free to unmute yourself or to write something within the chat box so that you can understand, right? So I'll try my best to deliver the best of content. What you need to understand is business statistics. It is a mathematical subject, so it's very practical. It's not theoretical, so do much of calculation. So I'm going to show you step by step, maybe certain subjects, certain things, so that you really understand. So today is just an introduction for you guys to understand the manner in which I would deliver my lectures, right? So without further ado, let me show you. Okay, let me just show. So I've shared the screen, right? So this screen has got an example of an assignment in business statistics, right? So that's the one that I'm going just to show you how step by step, how do you calculate this and so forth. So this is actually an assignment, right? It's not something that made up. It's actually an assignment from Mancosa, right? So the following data give the hourly wage rates for sample of 20 workers selected from a large company. All right, so you can see that these are the 20 people, the wages that the selected 20 people got, right? So okay, per se. So now these are the questions now that are asked from the information that you have been given above. So this question number 1 up to question number 6. So we're going to look at each and every okay. So you have to okay, sorry guys, there's something that just happened here. Let me. All right. Okay. All right, so let me go back. All right, so now I just want to start by defining what statistics is, right? So we start by defining what statistics is, and then we get straight to the questions. So before I answer those questions, maybe I'm just going to define 1 or 2 things so that you can have a background or an understanding of what I'm talking about, right? So let me start by defining what statistics is. So statistics, it is the branch of mathematics for 1, collecting, 2, analyzing, and 3, interpreting data. So for you to do what is called statistical analysis, you need to first collect the data, then you analyze it, then you interpret the data that you would have analyzed. So now, when you have interpreted that data, you can use that data to predict the future using what is called forecasting models, right? And then you can use those values to determine the probability of whether a specific event will happen, right? Or help answer questions about a survey, right? So generally, statistics is not only used in maths, it's used in business, it's used in medicine, it's used in biology, it is used in psychology, and sometimes it is used in social sciences. So it's not only based in or affiliated with mathematical department, but because of its ability to analyze and to interpret data, which can be used to predict the future, determine probabilities, and so forth, it has been embraced by various parts of other different fields. All right. So now that we have defined what statistics is, so for us to be able to answer, right, for us to be able to answer the questions that have been asked in this question, I need to define a little bit of some terms before we go any further. So let me start by defining what are called the measures of central tendency. Why? Because these are going to help us in what? In addressing the questions that I've highlighted above there. So a measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within the set of data. So what we are saying, a measure of central tendency, it is a single value. That is one value that is used to describe. So you are using that value to describe the set of data. Now you are using that value to describe the set of data by identifying what is called the central position. So those central positions, they're divided into three. So it can be the mean, it can be the median, it can be the mode. So the mean, that's your typical average. Then your median, that's the number that divides the data into two equal halves. Then the mode, that is the most frequently mentioned number, right? So now, that being said, I need to also define two things to show you that there are two types of data, right? Whenever you are given data, right, especially in business states, you can either be given it as grouped data or ungrouped data. So let me first define what ungrouped data is. The reason why I'm taking time to explain this is you understand later on when we do the lectures themselves, right, that the formulas, right, for measures of central tendencies to calculate mean, median, and mode, the formulas are different, right? For the formulas for ungrouped data, they are different from the formulas that are used for grouped data, right? So that's the reason why there is a need for us to differentiate the difference between the two. So the ungrouped data, it is the data that you first gather from an experiment or study, right? The data is raw, that is, it is not sorted into categories, classified, otherwise grouped, right? So generally, when we're talking about ungrouped data, we're talking about a set of data that is basically a list of numbers. Let me give you a very good example. Let's assume that you are having business states at Mancosa, and then your lecturer comes in, right? And then an example of grouped data, ungrouped data, is when the lecturer says, I want each and every one of you to tell me your shoe size. Then I'll be writing it down. So when the lecturer is asking the first student, what is your shoe size? Says 6, the other one says 9, the other one says 8, right? So the data, he is recording it as a list of numbers because that data is not grouped, right? So that's an example of ungrouped data. But now defining grouped data, we are saying grouped data is the data that has been bundled in categories, right? So once now you start to bundle up the information, the numbers, the list of numbers, then it becomes grouped data, right? So coming back to the example, we are saying the lecturer comes in. This time, It's not going to ask individuals and write it down. Now what it does is it say, I want people that have got a shoe size between 6 to 7 to stand in that corner, right? And it says those that have got a shoe size from 8 to 9 to stand in the other corner. And then the other guys that have got 10 to 11 to stand in the other corner. So what he is doing, he is categorizing and bundling people under a specific category. So each and every person will have a category that they will fall into. So what he's doing is he is grouping people based on the category that they fall into. Like, for example, I wear shoe size 7. So if it happened that I was going to be in that class, then I was going to fall into a category where people shoe size is between 6 to 7. That's where I would go into, right? So generally, that is the difference between grouped and ungrouped data, right? So now the assignment is given us the hourly wages of 20 workers. So the first thing to do is we need to sort the data in ascending order. When we're talking about ascending order, we are saying we are starting from the minimum value to the maximum value. That is what we are talking about. That is what we are concerned about, right? So generally, it is one of the easiest way. You come to realize later on that is one of the easiest way for you to deal with raw data, because one or the other are going to sort it anyway. So you start by sorting it in ascending order, and then it will be easier to work from there. So the first question is saying, right, using the raw data, determine the range. So remember, this is raw data. This is ungrouped data. It is data that is given as a list of numbers. It is data that is given as individual data points, right? So they are saying from the data given above, can you calculate what is called the range? So the range now, from your study guide, you come to realize that the range, it is the highest value minus the lowest value. So in this case, you come to check what is the lowest value. The lowest value here is what? Is 5.35, right? The maximum value is what? Is 15.90. Right? So you just say the maximum value, which is this one, minus the lowest value, which is that one, then you get your range, which is 10.55, as easy as that. So you need to understand that statistics is not that complicated, right? Some of you maybe might have a complex, maths. No. Statistics is so simple. As long as you adhere to the rules and the formulas that are used there, you see that it is so straightforward. So the second question is, what percentage of these workers get paid less than 10 rand per hour? So the good part of it is, since the data is already sorted in ascending order, so we can see all the people that have got wages less than 10 rand. So you can see that all these values here, they are less than 10, right? So the next value after this one is 10.8. 10.8 is out of the range. So that's why I had bolded it and underlined it, so that you can see that is our limit there. So I'm going to count how many people fall under whose wages fall under 10. So this is 1, 2, 3, 4, 5, 6, 7, 8. So they want percentage of people whose hourly wages fall under 10 rand. So there are 8 people that whose wages fall under 10 rand. But remember, how many people were selected? So the total number of people that were selected were 20 people, right? And 8 out of 20 people have got what? Has got an hourly wage which is less than 10. So now we want to find the percentage. So hence now we have to convert 8 over 10 over 20 into what? Into a percentage. So that's why we said here percentage is equal to the number of workers paid less than 10 rand per hour. There are 8 here, and the total number of workers, which is 20. Right? Which is 20 there. Then you multiply by the percentage, which is 8 over 20 by 100. That gives you 40%. Now, the third question, right? The third question is group the data into a frequency distribution with the lowest class limit of 5 Rand and a class width of 2 Rand and include the cumulative frequency. All right. So what you need to understand now is I need to first define some concept before I attempt this. So what you need to understand is when you are grouping data, right? When you are grouping data, you group the data using a table. So it's called a frequency table. When you include cumulative frequencies, it is called a cumulative frequency table. So it is just a table that you have what we call a class interval in the frequencies, right? You are just bundling, you are just categorizing the data that you have been given, right? You're just grouping it in simple terms. So now let me start by defining what is called a class interval. So a class interval is a term that is used to denote the numerical width of a class. So class, like for example, coming back to the example that I gave you earlier, where your lecturer is categorizing you into what we call classes, right? So the first category, which is 6 to 7, shoe size, right? That is the first class. So the first class has got an interval of 6 to 7. The second class has got an interval of 8 to 9. The third class has got an interval of 10 to 11, like that. So the class interval itself, right? Like the category itself, right? The category that has been set for that specific maybe size, right, is what we call the class interval. So what you need to understand is the class interval, right? It has 2 limits, right? Here. So there's a limit, there's what we call an upper limit of the class and the lower limit of the class. So these two is what makes a class interval. Like in this case, let's say shoe size 6 to 7. So 6 is the lower limit of that class and 7 is the upper limit of that class, right? So the class interval is from 6 to 7. So that's what class interval basically is. Now, the class limits, they are the lowest and the highest values that can be induced in the class, right? Like for example, a class width of 6 to 7, give that an example, right? So 6 is the lower limit and 7 is the upper limit, right? So those two boundaries, they are known as the lower limit and the upper limit of a class. So now understanding the lower limit and the upper limit of a class, let's look at what is called the class width. So a class width, it refers to the difference between the upper and lower boundaries of any class, right? So there are 2 ways of calculating the class width. So the first way, if you want to calculate the class width, you can say it is the difference between the upper limits of 2 consecutive or neighboring classes. All right. So for an example here, let's say we've got 6, right? Don't mind my language here. So this is 6 to 7. That's the first class, right? Then there's 8 to 9. Then there's 10 to 11. So this whole section with the green line here on the left. Okay. This whole section, right? Under the green line, these are lower class limits, LCL, right? Then all these are the numbers that are under the blue line. These are the upper limits, the upper class limits, right? So when you are given a frequency table, all the numbers that will be on the left, that's the lower limit. The numbers on the right, under the class intervals, right? On the right is the upper class limit. So when you want to calculate, right, the class width, when you want to calculate the class width, what we're just simply saying is if you are using upper limits, the numbers on the right, so you just say the difference between these two. So the difference between these two, 9 minus 7 is 2, then 11 minus 9 is 2. So there must be neighboring classes. You can't say 11 minus 7. No, there must be neighboring. That's why we are saying 7 and 9 and 9 and 11. You still get 2. The same with if you are using the lower limits, right? So if you're using the lower limits, again, if you find the difference between these two is 2, 8 minus 6 is 2. Even if when you say 10 minus 8, you still get 2, right? You still get 2. So the class width in the example that I gave you for what do you call it, for the shoe size is 2, right? So now what you need to do now is, the question here says you are supposed to group the data into a frequency distribution, which is a table. The table, so it will have 3 columns. The first one is a class interval. The second one is frequency, how many people fall into that class. And the last one will be cumulative frequency, because they said include the cumulative frequency. So you're just now adding up the frequencies of those classes together, right? So now, the lowest class limit of the first class must be 5, and then the class with itself must be 2. So we are to create that table. We are to group data and create the table using those 2 things that we've been given. So in this case now, you can see that I created a table for you, class interval, frequency, and cumulative frequencies, right? So you can see that the first class, the lower limit of itself, according to the question, must be 5, right? So which means that 5 in this case, that's what? That's the number that we are starting from. But then now remember, for us to determine the next class, the lower limit of the next class, we then say 5. We then say 5 plus 2. 2 is the class width, remember. We are saying 2 is the class width. So the class width, it is the difference between the lower limits. So in this case, we are just saying C, which is the class width. We are saying it is, in this case, we are using lower class limits, right? So we're saying it's lower class limit of class 2, right? Minus lower class limit of class 1. So in this case, our lower class limit of class 2, we don't know it as yet. Let's leave it as L, C, L2, right? Then class width we are already given because it's 2, right? Minus lower class limit 1. Lower class limit is what? It's 5. So if we want to find lower class limit 2, right, having this data, we then say lower using simple arithmetic operations, right? This becomes 2 plus 5. Which gives us 7. So, which means that's the reason why the second class is starting with 7. The next class, again, you just say 7 plus 2, which gives you 9. 9 plus 2, which gives you 11. 11 plus 2, which gives you 13. 13 plus 2, which gives you 15. Now, when do you know to add? The maximum value tells you, because the maximum value is 15.09, right? Should be 15.09. Let me just double check, right? 15.09 or 1590. So you know that obviously you can't go beyond that, because the maximum value there is what? Is 15.90. All right. So now that we have completed the lower limits, right, on the left side. Now, for us to complete the upper limits, right? So since here, obviously, we are starting for the next class, we are starting on 7. So it means that the upper class limit of the previous class must be 6.99, because they must not overlap, right? We can't have a 7 and a 7 here, right? Unless maybe your lecturer tells you, but if it is us creating, we can't have 7 and a 7 there, because these are decimals, right? So we can have 5.00 to 699, right? Then 7.00 to 899, 9.00 to 10.99. So you can see that to prove that this is correct, if you say 8.99 minus 6.99, you still get 2. 10.99 minus 8.99, you still get 2. So that is how you create class intervals. Don't worry, if you don't understand this, I'm going to repeat this in the lectures, right? This just to show you the manner in which I conduct my lectures, right? So if you don't understand it again, don't worry, right? We are going to cover it again in the lectures that we're going to have later on. So now what we need to do now, we need to group the people using their hourly wages, right? We have already established the class intervals. So we want to see how many people fall into this category of 5 to 699. So we come back to the data, right? So the good part of it is we sorted it out so we can easily see. That's why I was saying it's easy, you know, if you sort data out. So now what we do is we want values from 5 to 6.99. right? So these are two people. So this one and this one, they fall into this range. The third one does not fall. So we come and we say, how many people fall into this range? The frequency is 2, right? Then we come back again from 7 to 8.99. 7 to 8.99. So is this 3? Can you see? This 3. Right? So you come, you write your 3 there, right? Then 9 to 10.99, 9 to 10.99 is this one. So it's 4, right? There it's your 4. So you keep on doing this up until you fill in this 2 columns. Now, for the cumulative frequency, what you need to understand, the first rule is for cumulative frequency, the first cumulative frequency of the first class, right? So this is the first class, right? So the cumulative frequency of the first class, it's equal to its frequency. It only applies to the first class, right? So since the frequency is 2, the cumulative frequency is 2. But now the cumulative frequency of the second class, what you do now is you say, right, the cumulative frequency of the previous class, which is this one, plus the frequency of this current class, which is 3, must give you the cumulative frequency of the current class. Let me repeat that again. If you want to find the cumulative frequency of the current class, you say cumulative frequency of the previous class plus the frequency of the current class to give you the cumulative frequency of the current class. So it's 2 plus 3 to give you 5. So in this case, you say 5 plus 4 to give you 9. In this case, you say, we want to find the cumulative frequency for this class, right? You say this class plus, this value plus this value to give you 14. Then 14 plus 4 to give you 18. Then 18 plus 2 to give you 20, right? So don't worry, I'm going to repeat this. If you didn't understand, don't worry, right? We're going to repeat this when we go in detail. So this is generally how you create the cumulative frequency table or group the data in a frequency distribution. So now let's go to the next question, which is determine the mean wage rate using the raw data. So now there to be specific, because remember, we have grouped data, we have ungrouped data. So the formula for finding mean for ungrouped data is different from the formula that is used to calculate mean for grouped data. So that's the reason why they were specific mean wage rate using the raw data. Because already we have grouped and ungrouped data, right? So they had to be specific, right? Which formula are you going to use? So the formula that you're going to use is for the raw data. So for the raw data, right, which is this data that we've been given, right, in individual data points, right? So the formula I had written it down for you, which is mean is equals to sum of all the observations over the number of observations. So now if we add up the observations, what are we adding here? So we are adding all these values, right? We are saying 5.35 plus 6.25 plus 7.25 plus 7.5, blah, 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 up until to 15.9. When you add everything there, that is the sum of the observations, right? Over, right, the number of observations. When we're talking about the number of observations, how many people took part in the observation? These are 20 people. So now in this case, when you add everything, you get 223.2 divided by 20 people, right? And then you get your mean, which is 11 Rand 16, right? As easy as that, right? And then the next question, right? The second from the last question, they say draw an Ogive curve corresponding to the data and use it to estimate the median. So now, Ogive curve, you are to draw what? You are to draw a curve, right? So what is called an Ogive curve? It is when you plot the curve, right? Where you, okay, so when plotting the Ogive curve, you plot the upper class limit with the cumulative frequency. So you come back to this table. So this table, you have to take this column, these values, those are you will be your Y values. And then you only take these values, okay. These values in red. So those values in red, under that red box, those are the what we call upper limits. So you are plotting upper limits versus cumulative frequency, right? So in this case, let me do this. So upper class limit, which is this, versus cumulative frequency, which is that. When this is your X values, this is your Y value. So when you plot, you get this value there. Right? So you get this curve, right? So this curve there is what is called the Ogive curve. So how do you determine the median? So remember, we said as we were starting that the median, it is the value that divides data into two equal halves. So in this case, you come on your Y-axis, you check the highest number there. The highest number there is 20. 20 when you divide it by 2, because we want to look the value which divides the data into two equal halves, right? So you divide this by 2, then you get your 10. Then when you get your 10, you draw a horizontal line from 10 up until it crosses the curve. When it crosses the curve, you then draw another value that goes down, right? That goes down to the horizontal axis. So the value that you get here, the value that you get when this line crosses this what? Crosses this value there. The horizontal axis, that is the value. So I have estimated it to be 11.40. So someone might say 11.45, someone might say 11.30. It's okay as long as it's closer to there, right? If you write like 12, that's way off, right? You can see that 12 is somewhere here, right? So obviously it has to be less than 11.50, right? Between maybe 11.20 to 11.45. It's fine. So that is how you calculate the Ogive curve there. So so generally, guys, that is okay. Let me just do the last one, because the last one is just what do you call it? It's basic maths. It's not something which is within statistics, right? So I didn't want to what do you call it? I didn't want to confuse you guys, because this is just basic maths. But I've already written it, because I'm going to share the document. The answer is there, but since this is just an introductory lecture, I'm just going to leave this. I'm not going to explain this, because I don't want to confuse people, right? To confuse you, because this is not part of statistics, just basic maths, right? We had already calculated the mean, so they were just playing with you, right? They were just playing with you to see if you understand, what, if you understand how to calculate the mean, right? So generally, this is an overview of how I'll be conducting the lectures. Unfortunately, it is an offline thing, so I would have loved feedback from people. Like I said, it's an interactive lecture. I tend to get feedback sometimes in real time when I do the lectures, right? So, but unfortunately, since this is offline, if you have any questions, please reserve them for the next time when we're going to meet. We are going to meet every Thursday at 7 p.m., right? Every Thursday at 7 p.m. So I'm going to be meeting with you guys this coming Thursday. And if you have any questions regarding this intro, right, we're going to address them there, right? And then maybe if we are done with the questions, and then we proceed on to, the getting into the stuff that is covered within your study guide. So guys, thank you so much. Have a great weekend, a great week. I will see you on Thursday. If you have any questions, please reserve them for Thursday. And we're going to meet 7 o'clock. All right. So thank you so much.